Today I'm joined by Jeffrey Kinsey. Jeff, thanks for coming on the podcast.
Yeah, pleasure joining you, Brandon.
Yeah, I'm looking forward to the conversation here. I think EV charging infrastructure such a critical piece in the puzzle as we try to decarbonize the transportation sector. Lots of good work being done, lots of misconception, lots of challenges to be overcome, and I think we're going to unpack a few of these. So would you mind kind of providing some context? So just real quick, some background on what is EverCharge and what are you guys doing?
EverCharge, we focus on doing fleets. We are a full stack EV charging provider. So we make our own hardware, we design our own hardware, we have electrical and mechanical engineers, we do our own software, what would typically be considered a CSMS, the cloud portion of it. We do our own installations, we do our own support. We are truly a full stack charging provider. The benefit that we bring with that is that we have a enterprise customer said, like, I'm looking for that one throat to choke when something goes wrong. I don't call multiple people. I just call someone and they can fix it. That's us. But yeah, very much a product focused company. We build our own stuff. We deploy our own stuff. We support our own stuff.
And what are the primary customer base or segment look like?
So we're focused on fleets, behind the backlot fleets. So someone who's got a bunch of vehicles sit behind the fence that need a charge up before they go out and do their daily job. We traditionally came from our MUD business, so high density dwelling, apartment buildings, condos, that type of stuff. We will be expanding. We do employee charging as well. We are expanding into a lot of those different segments that are doing, I'd say a lot of like L2 level stuff. However, we are full stack. We do DC as well. But right now we are primarily focused on fleets, like I said, because there are fleets now that understand that going EVs is not about the sustainability. I know that's definitely some of it, but there are fleets now that have fully figured out how to make EVs cheaper. That their gas fleet will be more expensive than their EV fleet. So when it comes down to, at some point, it's going to come down to a cold hard, like, can I run a fleet cheaper by deploying EVs? And when the answer is yes, it makes a very easy sale. So there's for a lot of reasons, like the fleet market is just a very easy place, or I'm gonna say more mature buyers for EV charging and EVs in general.
Yeah, I'm going to start with a very simple seeming question, which I don't think is that simple in reality. So what is the role of the charging infrastructure in enabling a fleet to successfully transition to an electrified fleet?
It's actually, yeah. I mean, at the end of the day, they have to get energy into their vehicles. We've been 100 plus years on gas and diesel, so that infrastructure is well known both in the public and private space. So we have, it's a mix. Some folks behind the fence, they'll have their own gas pumps, and they're used to, doing all the maintenance that you would have at a normal gas station, including, I've been to customer sites that have EV chargers, but also have their whole parking lots torn up with replacing their gas tanks. So yeah, like if you're a fleet manager, you have this job, you got to get energy into your vehicle somehow. You're used to doing it either by having a fuel truck show up at your private lot filling up your own gas tanks, or you've got some fleet cards where people are going to public gas stations and filling up their vehicles just like you would a normal public person, but you're using a fleet credit card in order to do that. But they know like it's so built in already. If I run a fleet, I know how to get gasoline or diesel into my vehicles. That's well known for them. And so there's this real interesting opportunity. It's one of those like kind of head scratching moments that's really interesting in EVs, which is not only do you have to put energy into your fleet vehicle, but you actually have this efficiency gain that comes with moving to EVs. And there's a shocking statistic. I don't know what it is for a smaller vehicle, but I learned recently that if you're on a class 8, like a semi truck, you're going to spend about 40, 50 minutes filling your vehicle. like it's a long time that you're just sitting around. And so like, the dwell times that we talk about charging of, a car has to be sitting there for a while. It's kind of a long time, even when you fill up a big gas tank as well. And so there's this interesting benefit essentially for these fleets. Yes, I have to figure out how to get energy into my vehicle, but the fleets that really understand how to transition to EVs, what they're doing is they're putting their chargers, they're putting their EV fueling where their operations already have their vehicles parked. So, for example, we have a large last mile delivery company that we're working with. We created a custom solution for them that allows them to essentially park their vehicles at the loading dock and then charge them there. And so then you start saying like, well, how long did it take me actually to fuel my vehicle? Previously, you'd go out of your way. You got to go to a gas pump. Either it's on-site or off-site. That driver is spending some time fueling there. But if the EV charger is parked, or if the EV charger is where the vehicle is going to be parked already, then the driver just goes to where they would normally park, plug in, walk away. If your dwell time is long enough, then the fueling time disappears. Mm-hmm. And so to go back to your question again of yes, like these fleet managers, they have to figure out how to integrate EV charging into their existing operations. But once they do, there's this huge opportunity that essentially fueling disappears. I feel like it's one of those things that's like this hero story of EV charging that like yes, I'm doing it for sustainability. Eventually, like this whole thing becomes cheaper. EV vehicles are just cheaper to build. They have less components. They're easier to maintain. And then my fueling just disappears as well. My operations doesn't have to go out of their way to fuel anymore. It's this like kind of win-win-win scenario that pops out.
Yeah. Go ahead.
Brandon, do you have I don't know if you have an EV, but like I have a Chevy Bolt. Like now driving a gas vehicle, like it's just painful for me because every time I come home, I'm lucky enough to have a charger at my house. Every time I come home, I just plug in. I drop my kids off at the school. I plug in. By the next day, like it's full, obviously. And I never think about fueling anymore. Like how long does it actually take me to fuel my car? I don't know, a couple seconds to plug in, a couple seconds to unplug. Yeah. I have 7-year-olds now; they're doing it for me, right? Like it's just disappeared. And that type of benefit that people are getting at home, they're also getting at fleet depots as well.
Yeah, and I think what you're describing, at least in my own mind, and I come from a manufacturing and systems engineering background, so like that's where my head goes. But like what you're talking about is good systems engineering, right? So like bad systems engineering is take an old thing, rip it out, put the new thing in its place. Take gasoline recharge, try to look at, okay, what is that? Well, it's you're putting a certain amount of miles of range into a vehicle in a given time frame. Let's try to do that same thing with a new technology. That kind of does what you're looking for, but you're just scratching the surface with the benefits of the new technology. What good systems engineering is zooming out and saying, here are the requirements for the system, here is the potential for all of this new technology bring, and let's figure out how this whole system can be optimized. Go ahead.
Yeah, there's this, you're hitting the nail on the head to be like, if I had a gas pump somewhere, I put that gas pump away from everything else because it stinks, it's complex, it's flammable, it just requires a lot of its own infrastructure. So yeah, like gas pumps are where they are because of the limitations of what the material is. But there's electricity everywhere. Like everywhere I'm going to park my vehicle, there's electricity. There's already wires running through the wall. They may not be at quite high enough level, but they're there already. So like to truly say like I'm going to think about the system differently, the constraints that I had, I'm not going to run a gas pipe funneling diesel like into like a loading dock area because that would just create its own other problems. But there's already electricity running through there. I might need a different type of conduit and wire to run a charger, but like it's very much thinking differently. The fact that like what I did with gas, I don't have the same limitations with what I have with electricity, and therefore I can come up with better system designs. Mm-hmm. I think one of the struggles, so you talk about like system, like because if you're a fleet or even if condo homeowners, like no one thought about the fact that their vehicle is going to be charged where it's parked. I feel like it's even harder for some of these fleets to say, I have a very highly optimized operations already that assumed that I'm going to put charging or I'm going to do fueling with gas at some other location. Now when you say, now I want to go put charging where I was using the vehicles already, that's there's a integration problem that's hard there. And so I'll pick on a loading dock. There's not a lot of space at loading docks. By definition, you don't want to have a lot of extra space there. That's just wasted real estate and costs more. That means that us EV charging providers have to go way out of our way to make charging disappear into the existing operations that are already there. We've done very clever things, from hiding the chargers to essentially doing protections for where the cable's going to go. Like, we've done some very interesting things there. But you were going into sites that essentially weren't designed for EV charging to begin with, which makes these type of issues. Now, another thing, I don't know if you're going to lead in on this a little bit, like talking about system design again. The other thing is this: how long does a vehicle actually need to sit there to charge? So you said, like, yeah, if I was thinking about just replacing the gas pump with an electric charger, yeah, you're going to need a really fast electric charger if I'm going to drive a vehicle into a charger, charge there, and then move it to its final location to rest for the night. Yeah, you need a fast charger there. But realistically, if you're going to be parking a vehicle for a long time, like, you don't actually need a fast charge. That it's how much energy do you need over the time that you're dwelling there? It's a much smaller charge. And so I think that's what you're getting at, like those first principles, or like doing system design. If you step back and say, okay, I'm not a gas vehicle anymore, I'm an electric vehicle, you get very different, essentially, electrical infrastructure for charging.
Yeah, and you don't need to go from 0 to 100% or end at 100% every time you charge, right? You can trickle charge, you can opportunistically charge. Like, if you're parked at some place for 10 minutes and you're at 60%, like, it's fine if you drive away at 71%, right? Like,
yeah, like that. Like, I think fleets, that's an interesting one, because fleets fleets have this problem that there is still unknowns in the world. Mm-hmm. So I don't know, you get stuck in a traffic jam, or you have to make, like, something in your route, like, essentially doubles that day. I haven't seen folks that have been, like, amendable to the fact that I'm going to leave a depot with less than 100%. But there is a subtle little side effect to that, like what you said there, is that, like, yeah, I can trickle charge, but then trickle charging if I'm doing it every single day, if the EV charging infrastructure is so well integrated with my operations that, just like me, when I come home every day after dropping off my kids at school and I plug in my EV, if it's a similar, every day I go do my job, I come back when I park my truck, I'm going to plug it in, then you're never going from 0 to 50%. You're always going from, say, 70% to 90%, or 70, 80% to 100%. Mm-hmm. And so you still get that benefit of having, like, very little amounts of energy over a long period of time, but you still end up every day with 100% of your battery for your fleet leaving the depot.
Yeah, I got you. And that aligns with kind of the next question I was going to ask is, failure proofing the system, right? So, like, one of the things, I don't know, I've heard a case for wireless charging, which adds a ton of complexity, is that, like, you can't, if you park in the right spot and the wireless connection makes place, then you remove a failure mode of someone forgetting to plug it in. You mentioned there's uncertainty of, like, the drive conditions. Like, how do you, and I think this is painting with a broad brush, but I think generally people who are running fleets of vehicles are risk averse for good reason, because the cost of a negative event is very high usually. So how do you think about building the right level of confidence, right? So they feel confident in the system, but also you're not over designing it so that you, I don't know, have 6 DC fast chargers on backup just in case.
Yeah, the if I go back to my concept of nominal charge, and this is something that we really focus on. Like, if you've got say, I don't know, 10 vehicles that need 20 kilowatts every single night. That's not a crazy scenario. And I got to go, if I'm going to have one DC charger, yeah, I'm going to put in a pretty hefty big one, a single one. And then like you said, like that's really painful when that one breaks. So then I have to go put in like a second one to essentially back it up. If you, instead of doing that, if you say, well, I'm going to put in 12 L2 chargers instead, because clearly over a nighttime, 10 kilowatts, I can fill up 20 kilowatts, in 2 hours or so. I can dramatically like load balance at that site, still have plenty of power. And so to your point, like that does mean that instead of having like one very expensive piece of hardware, I've got 10 to 12 very low pieces of low cost of hardware. You get that redundancy that you need. And that's, I don't want to pick on DC. Like there's definitely times when you need fast DC, but what I do want to optimize for is the fact that like if a scenario doesn't need the faster charging, there's a lot of reasons to go with L2 with a slower charge. And you brought up one of them is that like, yeah, if I have 10 charging ports rather than one DC charging port, that's eventually going to be if one of them breaks for some reason, I don't know, a truck drives into one of them or some other maintenance failures. It's not that painful when I go from 10 down to 9 versus going from 1 down to 0. Mm-hmm. So yeah, there's a lot of, I'd say like there's a lot of redundancy built in to essentially using a slower charger just because you can put more of them in. There's another thing a trick that we play a lot. I talk about load balancing. That's something that we do a lot. Going back to my scenario, you got 10 trucks. They need 20 kilowatts per day. You could decide how big of a system do you actually need. Like you could say, if I did full speed on all those systems, then I would need 100 kilowatt power drop. But if I did that, I've overbuilt by a lot, right? Like, my trucks only need 2 hours of charge. Those other 10 hours that they're sitting there, that utility drop is doing nothing. Mm-hmm. Like you just built too much infrastructure. But what you can do is you could say, well, I'm going to build, let's say instead of having 100 kilowatt drop, I have, say, a 40 kilowatt drop. So easily on a nominal situation, the cars are going to charge. But let's say one of them like shows up pretty empty. Now that one that's empty can charge at a very high speed for the whole 12 hours that it's sitting there. So if it was empty, it will get full again. So once again, going back to your question, you can build into your systems, even with load balancing, you can build into your systems the ability to have like these like off cases or non-nominal cases to charge more for something that you didn't prepare for. I do see you talked about like backing stuff up. There is a pattern when fleets deploy L2, they'll also deploy 1 or 2 DCFCs as well. I hear numbers. I'm not in the fleet market, the vehicle market, but at ACT, there's folks talking about like a generic uptime about 95% for a vehicle. So that's actually 5% of the time it's in maintenance or unplanned maintenance. Something, tire pops or something happens, right? Even on an electric vehicle. And so the concept that it just came in at the end of the night, there's no time to do a slow charge. Like that's one of those scenarios that you would need a fast charge at that point. Yeah. But that goes down to the redundancy again of how many extra vehicles do I have? If I lose one vehicle, does that mean that a route's not running tomorrow?
Yeah.
Could be that the fleet has overbuilt the number of vehicles.
Yeah, and maybe you have some diesel, some hybrid trucks in there as well, right? Like I don't think we're necessarily talking about it needs to be a binary switch to all electric vehicles if you switch to one, right?
True. I'd say obviously I'm a little biased being in the EV charger market that I like everyone to move as fast as possible to EV charging because that feels like the right route. but you're right. Like there's always a backup. Even some of the largest fleets still have like some backup.
Yeah, I mean, to what extent? To what extent do you think the lack of risk tolerance is rational? And I guess the reason I ask is like the analogy to the way private citizens buy or lease their personal vehicles, right? Like it's it's the 1 or 2, 3 days out of the year when they need to take it on a road trip or whatever, and they like that's what they allow typically to paint their vision of like, oh, I might need this, so I'm going to go over buy my vehicle, and that's how you get a bunch of SUVs and just vehicles with more range than people actually need from a daily driving perspective. My intuition would be fleets aren't that far because they're TCO based and like there's dollar and cents and they have a balance sheet to work towards. But to what extent, yeah, do you think this is rational versus kind of fear based thinking?
So the part that becomes a lot more rational for fleets is that a lot of them have already deployed telemetry systems that are tracking a lot of stuff in their vehicles. They've been doing this for years. There's a lot of large players out there, Geotab, Verizon Connect, Samsara. There's a lot of players, Ford Pro. There's a lot of people out there, a lot of companies out there that do the tracking. And so for a fleet, they don't have to ask the question of like what is nominal and what is abnormal. They don't have to guess at it. They know already. So there's the subtleties that electric vehicles bring. If you have a gas or an ICE vehicle, and it's cold out, running the heater isn't going to dramatically affect the range or the energy that your vehicle needs because it's hot already. Where electric vehicle is going to have on a cold day is going to use quite a bit more energy. Mm-hmm. But for the most part, they're not guessing, and so they can already see essentially they can run their statistics of the average distance for specific vehicles. They know they can do the total population of 99% of the time my vehicle's only going to go so far. So for fleets, they don't have to work in the irrational zone that is consumer purchasing. They already know that, or I'd say a lot of the large ones already know that. I feel like some of the irrationality, I feel for some of these fleets, it's really hard to say I've been doing the same job or I've been innovating or the fleet itself isn't the innovation. This is something that they have to do, but they're not innovating that area. When they make the change to EVs, that's very different for them. There's a lot of new things that they have to figure out. They have to change that they've already figured out or they already had as repetition for decades. And so I wouldn't say it's irrational that they know where they already know what their vehicles need. What is hard for them to stomach is the fact that this is just change. They had part of a business completely locked down and now they have to change it. Yeah. And you see it's easy for me from Silicon Valley to be yeah, of course, change the world, break things, and you look at companies like Netflix who have gone through 3 major shifts as a company. But that's not what most companies do. Once you highly cost optimize a piece of your business, you don't want to go back and shift on it again. And so for them, I go back to the original who we are as a company, one throat to choke. As they decide they want to move over to electric vehicles and to EV charging, the number of companies or the number of products and services they have to bring in becomes a major lift for them. Mm-hmm. So their usage of the vehicles is very predictable, but the technological onboarding is not.
Yeah. So I mean, the trust factor is obviously huge, and I think anyone who isn't in B2B business type stuff, it's so easy to overlook or to look down on how much stock is put in trust, but I think there's good reason for it, but then also it is the way a lot of decisions are made. So when someone who's a fleet owner is going to make a transition to electric vehicle, they need to fundamentally trust that the vehicles are going to work and that the charging infrastructure is going to work. And I guess what you guys ultimately are selling here is we are your shepherd, we're your guide to assure that when you need the charging infrastructure, it's going to do what you need and that your fleet's going to be up and it's going to run, and you're going to be able to deliver so that you can generate profit and keep doing what you're doing. Is that fair? What am I missing there?
You're nailing it right on the head. There's like this there's this concept, or there's this misconception, I think, that like EV charging is easy. And I know, like, on some of your podcasts, you've talked to other folks about the difficulties. Like you're putting like high-tech devices out there in the physical world that are subject to a lot of variability: temperature, water, rain, even electrical infrastructure. Like when you plug in an EV charger, it is the grounding route for everything that's happening inside that vehicle. You know, that vehicle is sitting on top of rubber tires. Any electrical event that happens needs to go through the charging cable. So, like, the charging system is highly dependent on what's happening else in your building from an electrical perspective: voltage drops, grounding continuity. We're used to, from a software perspective, we're used to the complexities of trying to integrate two disjointed software platforms. And, I don't know who your normal listeners are, but like, if you're working in marketing or sales, try to integrate, like, say your customer marketing list with your sales marketing list, or your sales list, right? Like, those become very deep integrations, and you're trying to do the same thing now with EV charging. You're buying a piece of hardware that has to talk to another cloud management software service that is going to be doing maintenance, that might be talking to like customer support systems. Like there's a lot of pieces that have to come together to make all this work in a very complex environment. So you're saying, like, shepherding folks through this. Yeah, we've been at this for a while. Like, it's more complex than it looks. And so, we come out there knowing how all this stuff comes together, and essentially being that person or being that company that can figure that out for customers.
Yeah, and I think furthering the misconception that EV charging is easy is, like, the level 2 charger device itself, like, especially the one that you can buy in a residential setting that sits on your wall, like, that's not a particularly complex device from a hardware perspective, right? Those have more or less been figured out, and like, it's kind of become a commodity. But I think what you're explaining is everything that happens behind the scenes, especially when you're at a fleet scale or a multifamily building scale. Like, am I understanding that right?
That's right. Like, so like you take like a home charger, right? And you're like, okay, this is a glorified extension cable. But then when you start talking about fleet, MUD, anyone who's processing payments, anyone who wants reliability, then you start throwing in the whole concept of network reliability, right? Like, let's say you've got billing. So, like, in our MUD scenarios, right? Like the driver comes in, we charge them for the electricity. You have to have connectivity at that point, right? Like, that has to be connected. And one of the struggles that a lot of us in the industry have is that connectivity is not guaranteed. So, you see cell networks go down, even on site. Like, if you have, let's say you're relying on like Wi-Fi or Ethernet or something, once again, these are in real physical environments. So even with the EV charger, like being I wouldn't say simple device, but being a fairly robust device, like, let's say the Wi-Fi network that you have goes down because, I don't know, someone went into the server room at the site and, I don't know, stepped on your router or something like that, right? Then all of a sudden your whole EV system goes down. That's something that we do very different from other folks, is that, like, we don't rely on our day-to-day operations. We don't rely on cloud, cellular, anything. Like, if the whole rest of the internet world goes down, we're going to keep charging cars. Of course, that does mean, though, that, like, you don't have any insights or visibility until it comes back up again. But the concept that people are relying on the EV charging infrastructure to essentially get their job done tomorrow, or like in even an MUD environment, they're relying on the fact that their commute isn't going to happen if they don't get a charge that night, means that there is a level of reliability and a level of connectivity that exists for these more enterprise scenarios that you just don't have at home.
Yeah, and I don't know if this is gonna be a useful analogy or not, but so I'm more familiar with, I don't know, in the automotive, in the vehicle side, there's something like functional safety as a topic of, right? You have to put together a safety case for your vehicle, especially this is big for like the autonomous vehicle space, right? And it's essentially it's a logical case of what are all the ways that this thing can break, and how do you build redundancy at each layer so that you're not dependent on any single failure point. Is there a similar process or mindset to what we're talking about here in the software world, and what does that look like?
I would say in the software world, hardware world, definitely. So the safety tests that we go through like are very destructive. So to your thing, like we look for worst cases, lightning strikes, like high voltage situations, like if a battery dumped all of its power, like we look for those types of things. I think that from a software perspective, I'd say like we do something very different from everyone else. Like we are less reliant on other infrastructure, and the way that we do that is our EV chargers are meshed together. And so I feel like one of those it's one of those great uses of mesh. I know it's been bouncing around a while, but like I think we found like one of the use cases that just makes a ton of sense. That when you put a bunch of EV chargers out in a garage, like stuff happens. People run into things. Like a truck will back up into something. Like stuff happens. Life happens. And so the fact that if something goes wrong, it doesn't take down everything else, ends up being highly reliable. And so you're asking about what we do on the software perspective. Yeah, like we've gone way out of our way from both a hardware and software perspective to make sure there's not a single point of failure, because this is a line of business activity. Like people rely on these things. And so to roll back, if you go back to your last question, like how is this different from like a home charger? Like one, it's expected that it's going to be working for a lot higher uptime, like downtime. At your home, like be like, oh, my charger didn't work today. Like, okay, I'll just stop by a DC fast charger on my way to work. That's not really an option when you have fleets. And it's not really an option to have like, I don't know, a cloud service provider went down today. Therefore, your charging doesn't work anymore. I hate to. Seems relevant right now, like CloudStrike and Delta, like a lot of Delta customers, like they don't care the fact that like a software provider took out all of their scheduling systems. All they know is that they couldn't catch a flight home. Similarly, like an EV fleet or a fleet provider, a fleet company, they don't care that the cloud service provider went down. All they care about is the fact that their trucks didn't get the energy it needs. So the bar is a lot higher for a fleet installation, and it includes a lot more components than just the charger itself.
Yeah, and I don't usually love talking in terms of analogies, but another one comes like, right, I'm in the manufacturing world. There's a huge leap between what's good enough for building a proof of concept and what's good enough for steady state production at volume. And I think this is an example, right, of like if you're building a few of something in a garage or whatever, it's a reasonable assumption to be like, yeah, let's assume there's going to be Wi-Fi or cellular data or Ethernet, and like that's a reasonable assumption that most of the time that's going to be there. But if you set the bar significantly higher, like we can't afford for this not to work, so maybe we use those things when they're there, but like we need to have a plan in place that doesn't rely on something that's outside our control always being there. You have a significantly higher bar for that you hold yourself to from a product development perspective.
Yeah, there's that interesting statistical problem of like everyone has pretty high uptime. Like if you say like what are all the dependencies that I have, right? Like you don't hear about networks going down all that often. You don't hear about cell outages all that often. You don't hear about cloud providers going down all that often. But like if you look at your whole like essentially chain that's a part of your solution, and then you add up all the percentage of time that one of that chain will go down, all of a sudden it gets you in a spot where you're like, I don't really like where that ends up. You're absolutely right. And so like it's not that we take the viewpoint that we can't rely on anyone. We take the viewpoint on like things are going to fail. and when they do, they can't be catastrophic to us. We have to keep charging cars. If we can't report back what the energy is, we still have to keep charging cars. If we lose connectivity, we can't stop authorizing new charging sessions. If we have a vehicle run into one of our chargers, that can't stop the other ones from working. So there's this. What is the negatives of what could happen, even if they're at low rates, and we have to design around that so that people can rely on everything else. There's like this degraded service that happens when the rest of your value chain goes down, but at a minimum, essentially, vehicles still get the charge that they require.
Yeah.
And so one thing that's interesting about us as a company, now that we're kind of going full circle on this, is that like because we own our own hardware, we design our own hardware, we manufacture our own hardware, we can essentially pair some of those hardware features like mesh, that's very unique to us, with some of our software features to essentially make an integrated system that doesn't fail in the same ways that other systems do when they have outages. So like you're right, like it's really easy to get to the point where you have like a prototype or something that works. When everything else works, it works. It's really hard to get to the point when everyone else fails or something else in your value chain fails and you continue to work. That requires a dedicated focus.
Yeah, that's why, I mean, pilots in the real world are great. It's better than a pilot in a garage, but production for 2 months means a lot more than a single pilot that lasts, or whatever you want to call it, right? Like introducing it to real world chaos and statistical probabilities of, if you got 100 contingencies and they're all 1 in 100 chance to fail, like something's failing all the time.
Failing all the time, yep.
Yeah. So maybe side question. So I know you haven't always been in the charging space. Like why is this the problem that you're working on now?
So I spent a lot of time in consumer electronics. Not to throw any of my former employers under the bus, but like I wanted to make a difference. I wanted to do something that had some amount of value to society beyond just making something. And so the stuff that I had worked on previously, like a lot of things I learned in consumer electronics is applicable to what happens in EV charging. The embedded systems, the cloud connectivity, like even some of the mobile applications, like there is these overlaps between what had happened previously in consumer electronics and what EV charging is. So it was a very natural leap for me to be like, oh, I want to make a difference by doing something. This is a good place for me to do it. Like I'm not a chemist, so I'm not going to go invent like a new like concrete that's low carbon. I'm not a biologist, so I'm not going to go figure out how to have like cows release less methane. Like that's not my specialty. Like taking consumer electronics, applying what I've learned there and going and making EV charging like highly reliable, like that's definitely like in my wheelhouse. So yeah, I wanted to do something that was meaningful, and this was a good leap for me.
And yeah, that makes sense. And a lot of what we're talking about, right, is like this is simple enough to talk about, but complex to put into practice of like actually building out the system and having a hardware and a software team who work well, plus manufacturing and stuff. What's the most important thing that you believe or you've learned about what it takes to lead an engineering organization to actually put, a complex A to Z plan in place and actually go and execute on it in the real world?
Ooh, that's a topic for a whole nother podcast. I'll tell you about what motivates me, and I think it does trickle down at some point. I'm very mission driven, and we're actually really lucky here at EverCharge because there are customers that we have that are, I would say, they have their own missions, which doesn't necessarily overlap always with like EV and sustainability. Like they are doing things that require them to do EVs. And EverCharge as a company, we are providing EV chargers that we believe are far more reliable because of the system architecture. That is what motivates me, and that is what I push to the rest of my engineering organization of, like, if we are successful here, the world will be a better place. I have an interesting, I did a company all hands like a year and a half ago. There's some really interesting statistics that came out of the pandemic of here in California, like in my county, the reduced number of hospital visits for I think it was asthma during the pandemic when no one was driving gas vehicles. And it's hard to ignore. There is the whole carbon, like, global Earth warming thing that's going on. There's also, like, when you have a diesel vehicle that's idling outside of your door, you're like, oh man, like, can that guy move? This thing stinks. So, like, you combine essentially what's happening with just EVs in general, and then when you take it from a fleet perspective, EVs are expensive. There's no two ways about it. Like, hopefully, like, the next generation of cars get cheaper, they get more affordable for everyone to have. But when a fleet electrifies, everyone benefits from it. If the vehicles that are going down your street that you have no control over, like, there's a lot of vehicles that drive around that you don't own, there's services that maybe you don't subscribe to. If EverCharge is successful in electrifying those fleets, then everyone benefits from it. So, like, there's the highest order of, I'd say, of motivation for engineering teams is that the stuff that you're doing is going to matter. That this isn't just like another play to essentially go make money. This is something that, like, you will look back and say, I spent my best time in my engineering career working at EverCharge because what we did mattered.
Yeah. And what I'm about to follow up on is far less important than what you just said. So I appreciate you went there with the answer. But I guess I have to ask kind of one side question. So requirements, definition and capture, and program management are two sides of, like, what I think is within your organization that is so difficult to get right and so easy to screw up if you do a poor job, right, of, like, defining the wrong product and then having a product that timelines just are always. Do you have any specific resources or things, like, I don't know, someone new gets hired into your team and they're in one of those areas? Is there anything that you send them to be like, this is how you become good at requirements, definition, capture, program management, those types of things?
There's something that EverCharge has done for a long time now, which really I feel like resonates now more with the rest of the industry, the generic tech industry, than it has before. There's, like, we call it the 10% rule. 10% of your efforts gets you 90% of your results. And so you see, like, Facebook call it the year of efficiency. Like, you see all these layoffs happening in all these other tech companies. They know they've overhired. And there's this Twitter, like, really early on. I can't find this article again, so I don't know if I should quote it, but essentially they said that as engineering teams grow, the support required grows exponentially. So when you double your engineering team size, you're not actually doubling your output. It's exponentially getting slower and slower. Mm-hmm. And so if you can figure out how to keep yourself small, I mean, like, everyone, the concept of the 2-pizza team has been around for a long time. Like, keep your team small, keep them focused, like, truly do your MVPs. That means that you are not scaling yourself to the point where you're dealing with those exponential growths of large engineering organizations. I feel like we are very fortunate here at EverCharge that we have very large customers who are now telling us, they're telling what their problems are. And I feel like this is one of the funnest places to be. Like, when a customer says, I got this problem, I think I should solve it with X. Instead, you go back and solve it with Y. Something simpler. Once again, follow the 10% rule. Like, you're asking for something really complex. I'm going to give you something that's really simple that gives you the biggest bang for the buck. Like, customers are amenable to that. And I think one of the opportunities that we have so early in the market is that the transition hasn't fully happened yet. There are a few fleets that are fully committed to EVs that know exactly what they need. A lot of the other customers haven't gotten that far yet, and so they're willing to wait. They're willing to work with a company like EverCharge and be like, yeah, let's work on this together. Let's define this together. We have this need. What kind of solution can you come up with? And so to your point, Brandon, like, I think like if you're going out there, if you're a product manager or a program manager or an engineer is saying, like, I'm going to try to predict the future, but I don't actually have very good customer insights about what the problems are. That's where you get into the situation where you build something that someone doesn't need. Because especially in the fleet market, because the lead times are so long. Even doing utility upgrades, construction, the lead times are so long that you can have conversations with customers early, ask them what they need, like be creative about how to minimize that to an MVP and deliver before their infrastructure actually gets installed.
Yeah.
And so like it's definitely, I know other B2B companies like can play the same trick, even like in a pure software world. They can play the same trick of like, I'm gonna gather customers and then essentially build what they need. It's even easier, I think, in the EV charging industry where the lead times are so long with construction and utility upgrades that you can definitely have those conversations and build a very custom features for what the company needs.
Yeah, cool. I think that's a good place to kind of leave off. And I think this comment's redundant from a chunk of people listening, but there's still a perception. I want to highlight one thing you said about team size, right? Because there's still, for a while, it was, decades or maybe longer, it was headcount determines how successful or impactful your company is. And not only is that like no longer the case, but it's the inverse of the case in some situations of like impact per headcount is such a more important metric, and like how much you can get done with small team. Not only, I think maybe you highlighted the most important piece, but it also makes you so much more resilient when market conditions change or things evolve.
I took a pass through Amazon a couple of years ago, and they have their concept of the leadership principles. Like if you haven't read them, they're super interesting. They publish them.
Mm-hmm.
But one of the things they said was it's about delivering results. It's very simple. We measure ourselves by the results we deliver, right? And so headcount isn't delivering anything. Like you're not gaining any revenue, you're not gaining any value by having headcount. You deliver value by a customer saying what you delivered for me matters. So yeah, there's definitely a shift going on. You're right. That it's that revenue per head count that really matters.
Cool. Well, yeah, I think we covered a lot of ground, talked a lot up front about the importance of level 2 charging for fleet electrification, the changes that is being done there, how you guys have thought about, and also the importance of having a robust system that has good uptime. And then I guess on the back end, you let me pepper you with some organizational kind of more business type questions. Anything we missed or anything specific that you're hoping someone listening to this takes away from the conversation?
The one thing I'd say, like, especially if there's folks in the fleet industry that are looking at electrifying, I'd say find a partner. We try to be that company to be a partner, but I know we're not alone. There's a lot of folks out there that can help a fleet electrify. And it can be quite daunting. But, you doing this podcast, the future of mobility, like you're doing the same thing. Like you're like, there's resources out there. There's people that can help you do this. And so, the fact that we're all in this together, and someone coming into this new may not know where all of the pitfalls or problems might be. So yeah, if you're a listener, you're listening to this, and you want to go down this track, like there are folks out there that want to help you succeed. So find them, find us. We're here to make your life easier.
Cool. Well, yeah, really appreciate it, Jeffrey. Good best of luck to you and EverCharge, and yeah, thank you very much.
Yep, thank you.